Hello, welcome to this tutorial on how to use the MELFA robot connector in Visual Components. In this tutorial, we are going to go through how you can connect Visual Component simulation with a Mitsubishi electric factory automation robot in RT ToolBox3. For this tutorial, we will need to enable the Visual Components connectivity feature. So click on File, Options, Add-on, and make sure you have the connectivity feature enabled. If not, click to enable it, click OK, and restart the Visual Components software. Let's examine the current layout. The layout includes a Mitsubishi Electric RV4 FRL robot. The robot can be found from the e-catalog robot collection under Mitsubishi Electric and then searching for RV4 FRL, like so. Let's switch to the Program tab where we can investigate the current program for this robot. So what we have here is the main program. First, the robot moves to the waiting position, waits for a sensor signal for the pouches and for the boxes. And then once the pouches and boxes are available, we pick the pouches and place them into the box. Let's see that live in action. So first, pouches are coming. This section here fits 3 pouches currently. And once 3 pouches are there, the program will activate, picking them up and placing them into the box. Like so. All motion statements are set to use the base that is located at the robot's origin. As well, for the tool is a tool with 130 millimeter offset on the tool's Z axis. If you want to see how the signals are connected, and open the signal editor, where we can see that the robot's input signal 9 is connected to the conveyor sensor that's on the pouch conveyor. The input number 10 is connected to the conveyor sensor on this box conveyor. Output 100 is connected to the conveyor's power on signal, dropping the power on and off on the box conveyor. And then we have one more, it's still low. That's the output 101 that you can see over here. It's configured to perform the clustering and releasing actions with the current tool. You can configure this action. I close the signal editor, over the simulation, and go to the robot's properties and choose the action configuration. Here in the signal actions, I'll choose the output 101, and we'll see that when output 101 goes through, we do clasp, and on false, we will perform the release action. These parameters. Right now, the robot is using the built-in robot controller inside Visual Components. If you want to use external controls, I'll go to the component properties and choose the executor. And for the is enabled flag, I'll just disable it. Instead, what we want to do is use the RT ToolBox3 from Mitsubishi Electric Factory Automation to create a new virtual robot controller. In RT Toolbox, I'll choose New. Let's give the main VC Co-Simulation. Enter. You can give it a name or comment. Just click Next. For the robot model, we had the 4 kilogram version. RV FRL, like so. Next. Communication, I'll keep the default settings. Language as well. Next. Travel axis. Next. Additional axes. Next. For tool, we had the 130 millimeter offset inside visual components. So for tool 1, I just add 130 millimeters and click Finish. And let's just hit cancel here. And now we have a robot inside RT Toolbox. If we want to add the program from Visual Components, I'll jump back to the Visual Components side, like so. And in the Program tab, under Post Process, I can choose the Mitsubishi Download, and I'll create the main program and the subprograms under here. Then I will locate the folder where my RT Toolbox project was created. Open the RC1 controller for the program, and I'll paste my post-processed program in here. That's the main pick and place routines. Then I'll go back to RT Toolbox, Home, I choose the Update Project, and now under Program we can see the main pick and place programs. Now I can switch on the simulator mode and test my robot program that was created in Visual Components using this virtual robot controller inside RT Toolbox. So select the program, main, servos are on, click Start, and the robot moves, but since it doesn't get any input signals, it doesn't do anything more than that. So for now, I'll click Stop and Reset. I could also jog the robot using these handles, but let's get to that later. Now, if you want to connect this virtual robot controller with the simulation Visual Components, I'll jump back to the Visual Components window. I'll go to Connectivity, and here I'll choose the MELFA robot connector, add server, and on the right hand side I see the options for this connection. If I would have a hardware robot controller, I could connect to it using the Ethernet interface. Right now I have the virtual robot, so I choose RT ToolBox3 as the interface. We see that we have the same RV4FRL robot on both sides. if we had more than one robot in our project, we could select it from the drop-down menus. Then we can also choose what signal points do we want to see in our connection. I'll just go with the defaults and test connection. Connection succeeds. Okay. Then I'll click apply to store these settings. And finally, I'll click here to enable the connection. Next, we want to pair some variables between the simulation and the RT Toolbox instance. So I will right-click on Server to Simulation to choose Add Variables. Choose to also include the signal maps so that we can see the robot's output and input signal maps. I'll choose the robot outputs. This is now server to simulation, so we are reading the outputs to the simulation from RT Toolbox. So I'll choose outputs 100 and 101. And from the RT Toolbox side, I'll also choose output 100, 101, and click Pair Selected. Note that the MELFA robot connector automatically connected the robot joint values for chosen robot. So joint 1 is in Visual Components, is connected to joint 1 in RT Toolbox, and so on. Next, for the simulation to server direction, we want to connect the sensor signals. So those were in input ports 9 and 10. And then on the RT Toolbox side, I'll also choose inputs 9 and 10. Click Pair Selected, like so. Now I can close the variable pairing window, like that. And I can start the simulation on Visual Components side. Note that the robot automatically switches position to the joint values that we received from the server. I've opened the Connected Variables view at the bottom to see what values are we getting from the server. Now we are ready to see the robot co-simulation in action. I will expand the Connected Variables view to see the currently connected variables. I will then unpin these windows to make some more space, and I will move Visual Components and RT Toolbox side by side, like so. Then I will start the Visual Component simulation. Notice how the robot moved to the same pose as the robot in RT Toolbox. Then I'll also start the robot on RT Toolbox side. And once we get the input signals from Visual Components, the virtual robot controller in RT Toolbox should start the operation, like so. Here we can see how the axis values and the signals are synchronized between RT Toolbox and Visual Components. To stop the co-simulation, I'll click Stop and reset on RT Toolbox, and I'll reset the Visual Component simulation. Thanks for tuning in, and see you next time.